Okay. Today, right now we are at the end of Unit 5, periodic motion. So after this unit, we'll have only one unit left and semester test review. So today our goal is to go through some of the questions, important questions from the Unit 5 post-test. So we'll work on around 10, 11 questions. So after that, you should be able to work on rest of the questions on your own. And for each question, I'll give you some times to think about that question, and then you will answer that question through the poll, and later I'll answer that question, okay? This first question is, the potential energy for a mass on a spring is proportional to the square of which of these quantities? So let me write formula for potential energy so that you can answer this question. Potential energy is denoted as PE, that is equal to 1/2 K times x square, where K is spring constant, and then x is displacement. X is displacement. Okay. Now you should be able to answer this question. So let me launch poll. In polling, okay, you can answer this question through the poll. Okay, and do your best. Even if you do it wrong, that's fine. Okay, I'll answer it again. I'm just collecting the information how much you already know. Let me wait for some time and then I'll answer this question. Let me in polling. Thank you very much. The correct choice for this question is D, that is displacement. We circle that. Okay, and you can see here potential energy is 1/2 K times x square, and x is displacement. That is, potential energy is proportional to displacement square. Now let's go to the next question. And then I'll write formula for, if you need formula, I'll always write formula for you, okay? A mass is stretched 4 centimeters from the equilibrium position of a spring. If the displacement is double, displacement is x, what can be concluded about the restoring force? And then according to Hooke's law, restoring force is directly proportional to displacement, and that is equal to product of spring constant times displacement. And negative sign is because force and displacement, they always act in an opposite direction. So use that formula and try to think about this question. As you can see that force is directly proportional to displacement. Think about that and then try to answer this question. I have already launched the poll. You can answer through the poll. I already got one correct answer. That's great. I'll wait for some time and then I'll answer this question. Okay, let me end polling. Most of you have answered it correctly. Thank you very much. I really appreciate it. The correct choice is it is doubled, and that is B. So force is directly proportional to displacement. So if displacement is doubled, force is doubled. If displacement is tripled, force is tripled. So now in this case, displacement is double means force is also double. Now let's go to the next question. This question is, which statement describes the velocity of a mass oscillating on a spring? Okay, and then let me make a diagram. Let us suppose this is the spring on a equilibrium position where displacement is 0. We don't have displacement, x is equal to 0. Now we hang certain object so that it stretches a little bit more. This is the mass. And then let us suppose, let me make another diagram, okay? This is too much long. Okay. This is equilibrium position. If we hang, just to make that. This is equilibrium position. And then when we hang a mass, and if it starts to oscillate and it goes back and forth, let us suppose it goes all the way to down here, and this is A, it goes all the way up here, B, and this is the equilibrium position when displacement is 0. And here at A and B, displacement is maximum, B also displacement is maximum. So that means it goes back and forth or up and down like that. Now think about what will happen its velocity as at a position where displacement is 0, at a position where displacement is maximum. Okay, and try to answer this question. I'll give you some time. Try your best. Okay, it's fine even if you do it incorrectly. Okay, let me in polling, then I'll answer this question. Let's go through each of those choices. Okay, first one, the velocity is constant throughout the motion. Wrong. This is not the correct. It varies. The velocity remains throughout the motion. False. Not correct choice. The velocity is 0 at the maximum displacement. So yep, that's the correct choice. So whenever the mass on the spring goes up and down, at this point, when displacement is maximum, its velocity becomes 0. And its velocity is maximum when displacement is 0. And again, here at point A, when displacement is maximum, its velocity is 0. So the correct choice is C. Now I'll pause here for some times. If you have any question about this problem, please let me know. Okay. You can ask question through chat as well, or you can just unmute and ask me that question. Okay, thank you. Now let's go to the next question. The question is, what is the force applied by a spring as it stretches upward 0.25 meters and K value of 25 newtons per meter? So we have to calculate force, and then we know that displacement, that is 0.25 meters, and spring constant is 25 newtons per meter. That is X, and then we do have K, and we know that according to Hooke's law, force is a product of spring constant and displacement. But in this case, we are just calculating magnitude of force, so we can remove that negative sign and use just Kx. So let's plug in those values. K is 25, X is 0.25 meters. Once we substitute and multiply those two, we'll get around 6.25 newtons. And then if we round it to two significant figures, it becomes 6.3 newtons. So the correct choice is C. I just want to make sure that all of you got this problem. If you understood this problem, please give me a thumbs up or any other reaction. Now let's go to the next question. The question is, if you know that period of a pendulum is 1.87 second, that is T, period of pendulum, capital T. What is the length of that pendulum, capital L? Assume that we are on Earth and that gravity is 9.8 meter per second square. That is oscillation of gravity. Okay. So we do have some information already, that is time period and oscillation of gravity. Using those information, we have to calculate time period of the length of the pendulum. So we know that you can use this formula. Time period is 2 pi times square root L over G. Okay. Now I do have a question for all of you. How can we solve L from that equation? T is equal to 2 pi square root L over G. You can unmute and answer that question, okay? Or write that question through chat. I'll give you some time. Okay, now let me do it. First step, you have to square on both sides, okay? Because here we are solving for L, okay? That is length of the pendulum. And then that L is under this sign, you see that square root. So first step, square on both sides. Let's do it, square on both sides, like that. So on the left hand side, it becomes T square. 2 square is 4. Pi times pi, pi square. And square and root got cancelled. So it just becomes L over G. After that, our goal is to calculate L. So we want to get rid of 4 pi square and G. To get rid of 4 pi square, divide by 4 pi square on both sides. And then to get rid of G, multiply both sides by G. G got cancelled, 4 pi square got cancelled. So L becomes L is equal to G times P square over 4 pi square. Let's substitute those values. G is 9.8 is given. P square is 1.87 square. And then divide by 4 pi square. And you can use Desmos or any other calculator to calculate that value. And once you calculate, you will get around 0.87 meters. So the length of the pendulum is 0.87 meters. I'll pause here for some times. I know this question is a little bit difficult compared to other questions. It involves calculation and algebra. So if you have any question, please let me know. And if you think you understood this question, give me a thumbs up or any other reaction. Now let's move on. Let me read the question. Beside the force due to gravity or G, what else determines the period of a pendulum? And then period of a pendulum T is equal to 2 pi square root L over G. L is length of a pendulum and G is oscillation due to gravity. Okay, let me launch poll. I have launched the poll. Make sure to answer this question through the poll, okay? And those who will actively participate will get extra points in your unit activity, post-test, quiz, etc. Okay. I want to encourage all of you to take participation. Okay, thank you. Let me end polling. So as we can see here, period of the pendulum depends upon length of the pendulum and g, that is oscillation due to gravity. So in that case, what else determines the period of a pendulum beside force due to gravity? That is length of the cord. Correct choice is C, length of the cord. Now let's work on the next question. The question is, when a pendulum is at the position all the way to the left, when it is swinging, what is the true of the kinetic and potential energy? So think about when the pendulum is at extreme position. Okay? In this case, suppose this is equilibrium position at the middle. Now the pendulum is here. Pendulum always goes back and forth like that. So at this position, suppose it is A, B, and C. At position A, think about its kinetic energy, its minimum or maximum or zero. Similarly, think about its potential energy. And here you do have a diagram as well. And try to answer this question. Let me launch the poll. I already got one correct answer, I think. Let's see. Yep. I'll wait for some time so that everybody can answer. Okay, let me end polling. Thank you very much for your participation. So A and C are the extreme position. Okay, and then B is the middle position. You can think in that way. Here on A and C, velocity is 0. So that means kinetic energy is 0, 0, potential energy is maximum. At position B, velocity is maximum. That means kinetic energy maximum and potential energy 0. So the correct choice for this problem is B, that is the kinetic energy is 0 and the potential energy is maximized. Now let's work on another problem. The question is, what is the centripetal oscillation? Centripetal oscillation, that is denoted as A, that is oscillation, of a small laboratory centrifuge in which the tip of the test tube is moving 19 meters per second in a circle with a radius of 10 centimeters. So we do have velocity here. Magnitude of velocity is 19 meter per second. That is velocity. Radius is 10 centimeters. So radius is in centimeter. If you look to all of the choices that is provided here, you can see meter per second square, meter per second square. So we have to convert that centimeter into meter. 10 centimeter is equal to 10 divided by 100 meter. So to convert meter into centimeter, sorry, centimeter into meter, we have to divide that by 100. That is 0.1 meter. Now I'll write formula to calculate centripetal oscillation. That is centripetal oscillation is equal to b square over r. B is magnitude of the velocity, and this is r. Okay, this is r radius. Use that formula, plug in those values, and answer this question. Okay. I've already launched the polling. Okay, keep working, everybody. Okay, let me end polling and then answer this question. Thank you very much. So let's substitute those values. Velocity is 19 square over r is equal to 0.1 meter. And then use calculator and calculate that value. You'll get 3610 meter per second square. That is the unit of oscillation. And then if we write in scientific notation, it's 3.61 times 10 to the power 3. So we have to move the 1 decimal, 2 decimal, 3 decimal. So that is 10 to the power 3 meter per second square. So the correct choice is B. B for beta. Now let's go to the next question. This question is exactly similar to the previous question, but this time we have to calculate centripetal force. Okay, that's the only difference. And then centripetal force, let me read the question, sorry. What is the centripetal force that would be required to keep a 4 kg mass moving in a horizontal circle with a radius of 0.80 meters at a speed of 6 meters per second? We have to calculate centripetal force. Mass is given, radius is given, and velocity is given. So let's go back. We know that centripetal oscillation is b square over r. So force is always equal to product of mass and velocity. Sorry, mass and oscillation. Oscillation is b square over r. B square over r. So it becomes mb square over r. Now let's substitute those values. 0.4, that is mass. No, sorry, not 0.4, it's 4. Let me erase it. It's 4 kg. B square is, where is B? 6. Yep, 6.0. And then R is 0.80. Substitute those values, and then we have substituted those values and calculate it using calculator. We'll get around 1.8 times 10 to the power 2 newtons. And then centripetal force always act radially inward. Okay, so you do have two choices. You can see here D and E. E is incorrect because centripetal force does not act radially outward. It is centripetal force It always acts radially inward. Let's see from the diagram as well. It acts radially inward. I'll pause here for some time. If you have any question, please let me know. If you understood this question, please give me a thumbs up or any other reaction. Okay, now let's go to the next question. This question I'll work by myself. Okay, it involves a lot of algebra skills and then calculation. At first, I'll read the question and I'll read the question, write all those given information, and then we'll work slowly. A planet Jupiter revolves around the sun in a period of 12 years, that is 3.79 times 10 to the power 8 second t. What is the mean distance? Mean distance is r. From the center of the sun, the mass of the sun is capital M, 1.99 times 10 to the power 3 kilograms. And then we do have some of the information provided, value of G, capital G, that is universal gravitational constant. And then formula we do have here, T square is your 4 pi square over Gm times RQ, and pi is constant. Let me write that formula. T square is 4 pi square over Gm times RQ. So here our goal is to calculate R. So at first let's isolate RQ. Okay. To isolate RQ, let's multiply both sides by Gm and divide by 4 pi square. 4 pi square. So 4 pi square got cancelled, Gm got cancelled. So RQ becomes Gm times T square over 4 pi square. That is the first step. After that, think how can we solve for R, because this is R cube, okay, R cube, but we have to solve for R. Okay. To solve for R, we have to take cube root on both sides. Cube root, cube root and cube will get cancelled. So on the left hand side, it just become R, and the right hand side, it becomes cube root Gm T square over 4 pi square. After that, let's substitute those values, okay? G is, capital G is 6 cube root 6.67 times 10 to the power negative 11. Put in parentheses, multiply. M is mass of the sun is 1.99 times 10 to the power 30. T square is 3.79 times 10 to the power 8 square. Okay, 3.79 times 10 to the power 8 square. And then 4 pi square. 4 times pi is 3.14. 3.15 square. Okay. And this is a multiplication, okay, in between. Let me put multiplication sign. Okay. And then after that, use calculator. You can use Desmos or any other calculator. And then you will get it around 7.8 times 10 to the power 11. 11 meters. That is the mean distance from the center of the sun. Correct choice is E. I know this question is a little bit difficult, so I'll pause here for some time. If you have any question, please let me know. You can ask me question through chat as well, okay? And then give me a thumbs up if you understood this question. Okay, now let's go to the next question. This question is about Kepler's third law of planetary motion. And then according to Kepler's third law of planetary motion, Square of the orbital periods, that is t square, is directly proportional to the cube of their average distance from the sun. That is t square is directly proportional to r cube. So, so that means first choice is it is inversely proportional. That's incorrect. Okay, and then so let's look to the second choice. It's directly proportional to the masses. So wrong. Third one, square of the masses, wrong. Fourth one, the square of the orbital periods of the planets are directly proportional to the cube of their average distance from the sun. So that is the correct choice D. Correct choice is D. Now let's go to another question. The question is, what does Kepler's second law of planetary motion imply? So it implies that whenever planet is closer to the sun, it moves faster, and then when it is farther away, it moves slower. So in this case, the correct choice is a planet moves faster when it is closer to the sun. So we have completed around 11 or 12 questions from the post test. Now you should be able to complete unit 5 periodic motion post test. Okay, and then as always, if you have any question, please feel free to contact me. Now let's do one thing. Let me go. Okay, so I'll stop sharing my screen, and then